Hello everyone. In the previous session, we have seen what is a signal. We have also seen some examples of the signals. We have discussed few of the examples. We have also discussed about the classifications of signals, where we discussed what is the difference between one channel and multi-channel signal. We have also discussed what is the difference between a one-dimensional and multi-dimensional signal. And we have also seen that depending on the independent variable, a signal can be categorized or classified into two types, that is continuous time signal and discrete time signal. So in this particular session, we will discuss everything about continuous signal and discrete signal. So as you can see, a continuous time signal is defined for every instant of time, whereas discrete time signal is defined for discrete instant of time, or you can say discontinuous instant of time, or you can say at some integer points. So as you can see in this particular graph, this is my x-axis, which is actually my domain, or you can say my independent variable, and this is my y-axis, which is my amplitude axis, or you can say the value axis. So this particular axis depends on this particular time, so the function is x of t. Now you can see this particular graph, this particular signal is defined for every instant of time within a specified range. So if I choose a particular range, let from here to here, this is defined for every instant. This is defined for every instant. So it take all values from this time domain, from this time to this time. That is why we can say this is a continuous time signal. In the same way, if you can see here, this is my x-axis, which is represented in n, or you can say time in discrete domain, and this is my y-axis, which is x of n. So basically a discrete time signal or a discrete signal can be generated by sampling a continuous time signal that we will discuss in our future lecture, that how to convert a continuous time signal into a discrete time signal. So that is a separate session completely that we will discuss in our upcoming lecture. So for the time now, you just remember that in discrete domain, the x-axis or the time axis is always represented with small m, and the y-axis is always represented with x of n. So this value is a function of this particular time. And as you can see, this signal is defined for some discrete level of time. It is defined at -1, it is defined at 0, it is defined at 1, it is defined at 2, 3, 4, 5. But it is not defined between 1 and 2. So if you take 1.5, so this particular signal is not defined at 1.5. If you choose 0.5, then you can say this particular signal is not defined at 0.5 also. So this is what we call a discrete time signal. So a discrete time signal is defined for discrete levels of time. Next is a continuous time signal is continuous in time and continuous in amplitude. And a discrete time signal is discrete in time, or you can say discontinuous in time and continuous in amplitude. In other way, we can say that a continuous time signal has infinite number of values between any two points on time axis as well as on amplitude axis. So if you choose any 2 points on time axis, that I am choosing this particular point and this particular point, you draw a vertical line at these 2 points, and you can see that there are infinite number of values are present over here. Let this particular point is 1 and this particular point is 7, then I can say there are infinite number of values are available between the point 1 second and 7 second. such as 1.1, 1.01, 1.001 and so on. So infinite number of values are available between any 2 points on the x-axis. In the same way, if you choose any 2 point on the y-axis, let I am choosing this point and let I am choosing this point. So you can say that if this point is let 3 and this point is 4, between 3 and 4 we have infinite number of values available between these 2 points. So that is why we can say that this is continuous in time as well as continuous in amplitude. Now in the same way, if you can see here, a discrete time signal has finite number of values between any 2 point on x-axis, or you can say time axis, and infinite number of values between any 2 point on y-axis. So as you can see, if we will choose any 2 point on x-axis, let I am choosing this point and this point. So between 1 and 5, including 1 and 5 also, we have 1, 2, 3, 4, 5 number of samples. So the number of points between any 2 point on the x-axis is finite. That is why we can say this is a discrete or discontinuous in time. But if you choose any 2 point within a specified range on y-axis, or you can say on amplitude axis, let this is 1 and this is 2, you can say that between 1 and 2 we have infinite number of values available between any 2 points. So that is why we can say this is continuous in amplitude but discrete in time. So this is all about continuous time signal and discrete time signal. Next, the most important concept is analog signal and digital signal. So here we can discuss two questions. Are all continuous signals are analog? Are all discrete signals are digital signal? So these are the two very important questions that we will discuss at the end of this session. So before that, let us first understand what is an analog signal. So an analog signal is defined according to the dependent variable. As we discussed in the previous slide, that a continuous time signal depends on the time axis, or it is dependent on the domain. But in case of analog signal, if you want to define an analog signal, then you have to take the consideration of amplitude, or you can say dependent variable, or you can say values. So analog signals are defined according to the dependent variable. In the same way, digital signals are also defined according to the amplitude, or you can say dependent variable. So basically, in a digital signal, the amplitudes are actually quantized. Then only we get a digital signal. So the sampling of a continuous time signal produced a discrete time signal, and quantization of the amplitude axis produce a digital signal. Next is, here amplitude of a signal take all possible values in continuous range. It takes all possible values in a continuous range. Okay, we can say that if we have a signal like this is t and this is x of t, and if we have a possible range from 1 to 5, then the amplitude of the signal take all possible values in this continuous range. The amplitude of a signal is specified within a given range. Here the amplitude is quantized, okay, and the signal is specified, the amplitude of a signal is specified within a given range. It doesn't take all the values on the range, it takes some specified values. It will take some specified values within a range in the amplitude axis. Now the third point is, analog is all about measuring. But digital is all about counting of a signal, because in digital signal we know that a system takes only two values, that is 1 and 0. So basically it takes 1 and 0 for counting purpose only. So the next important topic is analog signals are not always continuous. It can also be a discrete signal. So as we can see here, analog continuous, or we can say continuous time signal, continuous time analog signal. You can see here that this is a time axis, this is amplitude axis, and within a specified range, the signal, we have the signal, the complete signal we have. The signal is completely defined within a specified range. So here the domain is continuous, and as the amplitude or the dependent variable has all possible values, or you can say the system takes all the possible values within a specified range, so we can say the signal is analog. So such type of signal are called as analog continuous or continuous time analog signal. Now let us see how a analog discrete or discrete time analog signal looks like. So we can see the same shape we have drawn here. This is my time axis, or you can say the discrete time axis, and this is my amplitude axis x of n. So as you can see here, the time is discrete, but the system takes all the possible values within a specified range in amplitude axis. That is why this, according to the amplitude or according to the dependent variable, we can say this is an analog signal. But depending on the domain, or you can say depending on the time, the signal is a discrete time. So we can say that this is a discrete time analog signal. So the next is digital continuous or continuous time digital signal. As you can see here, this is my time axis, this is my amplitude axis, and you can see this signal is continuous in time. It takes all possible values. The signal is continuous in domain, or you can say continuous in time. But you can see that even if my range in amplitude or in the dependent variable is -2 to 2, it takes few value within this range, only 1 and -1. It is not taking all the values of the dependent variable. The system is not taking all the values in the dependent variable. So that is why this particular signal is called a digital signal but continuous domain. So we can say it digital continuous or continuous time digital signal. But you can see here an example of digital discrete or discrete time digital signal. You can see the x-axis, which is n, and the y-axis, which is x of n. X-axis is discretized. It has some discrete level of intervals, 0, 1, 2, 3, 4, 5, 6, and so on. Even if the amplitude range is let -2 to 2, it is taking only discrete value. It is taking only quantized value on the y-axis, 1 and -1. So we can say according to the dependent variable, it is digital. But according to the domain or according to time axis, we can say this is a discrete signal. So this type of signal are called as discrete time digital signal. Now coming to our question, all continuous signals are analog signals? Then we can say the answer is no. From the whole discussion we can say the answer is no, because if this is time and this is x of t, and let my amplitude range, or you can say let the system is taking the values from my +1 to +5, and I have a signal here which is restricted to the point 2, which is restricted to the amplitude 2. So it is not taking all the values in amplitude axis. So such type of signals are continuous signal, but this signal cannot be called as analog signal because it is not taking all the values on the amplitude axis. So this is a continuous time signal but not a analog signal. Next is all discrete signals are digital signals. Then we can say that answer is no. Not all discrete signals are digital signals. as we discussed already, this is a discrete signal, discrete time signal, but it is not digital signal because it is taking all the values in the dependent variable. That is why this signal is not a digital signal. So all discrete signals cannot be a digital signal. So this is our second answer. So this is all about the concept of continuous signal and discrete signal, analog signal and digital signal. In the next class, we will see how to convert a continuous time signal into discrete time signal by the help of sampling. We will discuss about the sampling theorem, the Nyquist sampling theorem also. Thank you.